All right, these notes are going to first be a review of long division. And then after we review long division, we're going to do something called polynomial long division. So, you learned how to do long division a long time ago. The problem you might have done, for example, is you might have done, probably not something this big, but like 23,968 divided by 3. So if that was the problem that you were doing with long division, you would take the 3 and you would put it in the front, and then you would write 23968, you'd put that underneath. And what you would ask yourself first is, how many times does 3 go into 2? And the answer to that question is 0 times, so we wouldn't put anything there. So how many times does 3 go into 23? And the answer to that is 7. So 3 goes into 23 7 times. And after you have that, you would say 3 times 7 is 21. And you would subtract those numbers. So 23 minus 21 is 2, and then you would drop down the 9. And then you would ask yourself, how many times does 3 go into 29? And the answer is 9 times. And 3 times 9 is 27. So we would put 27 down here, and we would subtract those numbers. 29 minus 27 is 2. We drop down the 6. Next, we would say, how many times does 3 go into 26? And the answer is 8. 3 times 8 is 24. I swear I did not plan this out ahead of time. 26 minus 24 is 2 again. Goodness gracious. And we would drop down the 8. And then we would say, how many times does 3 go into 28? And the answer is 9 again. So 3 times 9 is 27. And at the very end, we would have a leftover of 1. And in elementary school, you wrote remainder 1, and you left the problem like that. Well, in this case, that 1 still needs to divide by 3. And so we're going to say that this would be 7,989, and the 1 is continuing to be divided by 3, so that's 1/3. So if you did 23,968 divided by 3, you would get 7,989 and 1/3. Which kind of makes sense, right? Because you're almost at 24,000, so 24,000 divided by 3 would be 8,000, and so those numbers are pretty logical. That's what we would expect. So we are not going to do long division because we're in high school now, but we're going to do something called polynomial long division. And to start with, we're just going to practice this as a skill that we need to learn and know how to do. And then after we get better at it, we're going to look at what types of problems polynomial long division can help us solve. So right away, if you say, Miss Rice, when am I ever going to do this in a job? I'm going to say, at this point, I can't tell you because you don't understand what you could use it for yet. So the types of problems we might divide here would be like x to the 3rd plus x squared minus 38x plus 47 divided by x minus 5. So again, we're going to set it up just like a long division problem. So I have x minus 5 in the front, and then x to the 3rd plus x squared minus 38x plus 47 underneath. Now with polynomial long division, the process is the same. There's just one part that we're going to word a little bit differently. So in the beginning here, I said, how many times does 3 go into 23? And we're going to word that differently. We're going to ask ourselves, what should I multiply x by to get x to the 3rd? And then other than that, the process is the same. So if you think about it, x needs to multiply by x squared to give you x to the 3rd. So we're going to put an x squared on top. Now, after you have that number on top, the process is identical to what we've done in the past. So then we said 7 times 3 is 21. So we multiplied the top times the front, and we stuck it underneath. So for this one, when we multiply the top, we have to multiply it by everything in the front. So the -5 has not made any difference to the problem yet, but now that we're multiplying the x squared by everything that I have written right here, now that -5 is going to matter. So x squared times x is x to the third, and you can see that I lined up my terms that were the same, the third exponent and the third exponent. And then x squared times negative 5 is negative 5x squared, and I'm going to line that underneath the x squared. So just like regular long division, our next step is to subtract. And this is where you have to be careful, because I'm going to go ahead and write subtract right here. X to the third minus x to the third, that's easy. But when we subtract a negative 5x squared, minus minus makes a plus. So I'm going to be adding this. So if I subtract negative 5x squared, it actually turns into a positive. So these two terms subtract to be 0, and if you're doing polynomial long division correctly, you're going to get 0 when you subtract those ones. Over here, I have x squared and 5x squared, and I'm adding those together. So if I have 1x squared and 5x squared, that gives me 6x squareds. And then after that, just like we do in regular long division, we take the next term and we drop it down. All right, so we're going to go through the process again. We're going to ask ourselves, x has to multiply by what to get to 6x squared? And the answer is it has to multiply by positive 6x. So I'm going to write plus 6x. And once I have the number on the top, just like regular long division, I can take the number on the top. So just like regular long division, I'm going to take the number that I got on the top and multiply it by the front, and then I can write that number underneath, getting ready to subtract those things. So the thing that I have on the top is 6x. 6x multiplied by x is 6x squared. 6x multiplied by negative 5 is negative 30x. And then I draw the line underneath, and I change the signs, because when you subtract things, you change the signs. So 6x minus 6x is just 0, which again is what I wanted. I should get zeros on the first term. And then if I look here, I have negative 38x and positive 30x, and that gives me negative 8. And now I can go ahead and drop down the next term. All right, my next question. What do I need to multiply x by to get negative 8x? And the answer is I need to multiply it by negative 8. So now that I have the number on the top, I'm going to take the number on the top and multiply it by both of those things that were in the front. So negative 8 times x is negative 8x. Negative 8 times negative 5 is positive 40. And when I draw the line underneath, I change the signs because I'm subtracting these things. And when I subtract, it makes it the opposite of the number. So negative 8x and positive 8x subtract to be 0, or they combine to be 0. 47 take away 40 is 7. Now at this point, this is kind of like our remainder. So I'm going to go ahead, let's not write remainder 7, but let's look back at the previous problem. So in the previous problem, we had remainder 1, and that 1 continued to be divided. We said 1 divided by 3 is 1/3. So for us, we have a remainder of positive 7, so I'm going to say that this is plus. I'm going to add something on the end, and the thing that we're going to put on the end is a fraction. This 7 is still being divided by x minus 5. So I'm going to say plus 7 over x minus 5. So if we did x to the third plus x squared minus 38x plus 47 divided by x minus 5, the answer we would get is x squared plus 6x minus 8 plus 7 over x minus 5. That is the answer to that division problem. All right, we're going to do one more example on this video. So here is the problem we're going to do. We're going to do x to the fourth minus 100x squared minus 4x minus 48 divided by x plus 10. So this problem has something in it that you have to watch out for. And the thing that you have to watch out for is you have to make sure that all of your exponents are accounted for. So make sure to to have all exponents. I don't know why I put an S in there. So exponents in decreasing order. So first of all, the polynomial long division only works if the exponents are in order, and on the previous problem they were. I have an exponent of 3, 2, this would be an exponent of 1, and then I have none, no exponent. Here they're also in decreasing order, 4, 2, 1, none. But here I've skipped one. I have the exponent of 3 is not being used. So I have to make sure that when I actually do this long division problem, that I put 0x to the third inside the problem. So I'm going to say that I have x plus 10, and this is x to the fourth, plus 0x to the third, minus 100x squared, minus 4x, minus 48. So the first question I'm going to ask myself is, x multiplied by what is x to the fourth? And the answer is x to the third. And then I'm going to take the thing on top and multiply it by both things that are in the front. So x to the third multiplied by x is x to the fourth. X to the third multiplied by 10 is positive 10x to the third. And then I'm going to go ahead and draw my line underneath them, and when I do that, I change the sign of each term. So x to the fourth minus x to the fourth is 0. 0x to the third minus 10x to the third is negative 10x to the third. And then I can go ahead and drop down my next term. So the next question I'm asking myself is, x multiplied by what gives me negative 10x to the third? And the answer is negative 10x squared. So negative 10x squared multiplied by x is negative 10x to the third. Negative 10x multiplied by positive 10 is negative 100x squared. So if I look here, I drew my line, I have to change my signs. And both of these become 0. So I have 0 right here and 0 right there. So I'm going to go ahead and drop down my next term, negative 4x. And here, if you guys notice, this usually didn't happen where both of these things zero out. So I'm actually going to go ahead and drop down my next two terms, because I might want to use both of them for my next step. And then I'm going to go ahead and ask myself that same question. So x multiplied by what is negative 4x? And if I multiply by negative 4, I could get negative 4x. And then I take that thing on the top and multiply by the front. So negative 4 multiplied by x is negative 4x. Negative 4 multiplied by 10 is negative 40. I draw my line, I change my signs. The 4x's cancel out, and negative 48 and positive 40 makes negative 8. And negative 8 is the end, and so this is where I get to write my fraction. This time my fraction is negative, so I'm going to say that I'm subtracting the fraction, and the fraction itself is 8 over x plus 10. So when I divide those things, I get x to the third minus 10x to the second minus 4 minus 8 over x plus 10.